Okay.
No, not the moon spins.
I gotcha.
Double check. This guy's fine.
So it's a bunch of things, so we can give them each short shrift.
No problem.
And there we go. I'm good to go. Thank
The
God.
news story about it says deep impact, so that's fine.
Sorry about what?
About the magma ocean on Earth.
Oh.
Are you recording? Ready to go?
Yeah, let me just flip the camera so it's facing me over there, so I'm gonna babysit the phone.
Sorry.
Yeah, should be good to go now.
Okay, I wrote the sponsor message in 30 seconds.
Yep.
So it's not a great one. All right, let me get some room noise. Okay, here we go. Ready? Yes?
Sure.
Sure? We'll see how it goes.
It's gonna be
All
a
right.
mess.
Welcome to Walkabout the Galaxy, the unstoppable astronomy podcast, where the science is universal, the opinions are personal, and the trivia is historical.
All right.
We are Strange, Truth, and Beauty, the astroquarks, also known as Josh Caldwell, Jim Cooney, and Zoe Landsman, coming to you from the Walkabout studios at the University of Central Florida. Our stumpers are avengical.
Uh-oh.
Ooh, dun, dun, dun.
We haven't seen it.
Any Avengers?
We've seen the
The
first
new
one.
You've seen the first
but
20,
not-
haven't you?
I don't know. I definitely have missed a few.
You've seen 75% of them
Yes.
probably, or
That's
something like
about
that.
right, yeah.
I'm aware that they exist.
Okay. All right, so we'll start with you then, Jim.
Okay.
Ant-Man or Wasp?
Ooh.
I know what he's gonna say.
Do you?
Mm-hmm.
You think I'm going to say the Wasp?
Yes.
Because that's Evangeline Lilly. Is that who
Yes.
plays that? And she is very cute. However, I'm going to go with Ant-Man because Paul Rudd is funny.
Oh.
But so is
Interesting.
So is Lily. But I like them both. I enjoyed both of those movies.
Were there two Ant-Man and Wasp
There was,
movies?
There was
there
one-
was an Ant-Man and then there was an Ant-Man and the Wasp.
Okay, was the Wasp in the Ant-Man?
No.
Well,
Okay.
Well, yes.
yes.
She
Just
was,
not
but not
as
as the Wasp. Right.
correct.
Okay.
But anyway, I think they're both great.
Okay.
But I'm going to go with the Ant-Man.
Sounds like you're hedging
I'm
your bets
hedging my
your
bets.
bets a little bit. All right, Zoe. Captain Marvel or, can you guess?
Captain America?
Yeah.
I'm gonna say Captain Marvel. I enjoyed that movie, girl power, etc. Although if there's a friend of mine who'd be very angry with me if she's listening to this because
Oh, really?
she loves Captain America.
Okay.
Sorry, Natalie.
Which one outranks the other?
They're both captain.
They're both captains, and they're both
They
captains.
both answer
in-
to admirals.
And they're both captains in the U.S. Armed Services structure. I mean,
Right.
both of their
Mm.
ranks come from the U.S. military.
Yeah.
But different branches or something, right?
I guess.
Isn't
She was in
Captain
the-
America was in the Army?
Yeah, and Marvel was in the Air
Air
Force,
Force.
although it wasn't clear to me at any point that Captain was any kind of a
She was a
designation
captain.
that she had.
Oh, absolutely. She was a
a
captain.
captain?
Yeah, she was
Okay.
a captain. And so her friend, her other captain friend's daughter, they nicknamed Lieutenant.
Yeah.
Yeah,
Okay.
that's
She was a
right.
captain.
She was a captain.
Yeah.
But she
But not
wasn't in
Captain
the,
Marvel.
She wasn't Captain Marvel, right? In the movie, like there was a different character named Marvel or
Right.
whatever, but then she
Well, and
wasn't.
she was just like, I'm gonna do this in her honor or something, is what I.
Yeah, but there's no designation of her as Captain Marvel
Yeah.
in the movie at
That was
all.
weird.
Even after the movie is over, just like, okay, there's somebody else named Marvel, and she is Captain Jones or whatever her name was. I don't really remember. Today, impacts large and small is the theme today. There's a baby crater made by people on an asteroid.
Aww.
I don't know exactly how baby it is, but I think it's pretty small. So we have pictures, but without a scale bar, so I'm not
Yeah.
sure how big it is. So, do you know?
I don't know. The impactor was pretty tiny though, right?
It was not a huge impactor, and it was traveling fast, and I'm not entirely sure whether it was propelled by an explosive charge or whether it was supposed to detonate with a chemical explosive charge on impact. We'll come back to that
This
a
is
little
when we
bit
need
later.
charm quirk.
Charm Quark will
Oh,
be all over
yeah.
that.
Should we mention that we're missing Charm Quark today? It's very sad.
Why are we missing Charm Quark? She's been off
And
launching rockets.
undisclosed
No, it's
location.
disclosed.
Oh, the location's
The
disclosed.
location
Okay.
is disclosed. She is returning from the West Texas launch site of Blue Origin, following yesterday's successful flight of the New Shepard suborbital launch vehicle carrying one of her payloads, studying, as it happens, stuff on asteroids, asteroid stuff, as we call it. That's a technical term.
Asteroid stuff.
So she's missing talking about science to do science.
Yes.
Fair. Update. 20 meters wide was the impact crater on Ryugu, which is
Oh.
larger than the team expected.
It's larger than I expected.
That's larger
Yeah.
than I thought, looking
Yeah.
at the picture.
And
I mean, I guess
also
you-
from looking at the picture, it's larger than I thought, and I think that
Those boulders are
highlights.
big.
That's exactly right. It highlights that there's not small pebbles and things. So you see stuff and you're like, oh, those are little tiny rocks, so that's a little tiny hole.
Yeah. Same with Bennu too. I mean, you see the rocks and you think, oh, it's like hand size, and it's like, no, that's
Car
Tractor
size
trailer
or
size.
something.
So it's really
Yeah.
nice to have scale bars on pictures. I looked at that
Yes.
picture and had no concept of how big it was.
Well, our colleague Dan Durda at Southwest Research Institute made a really handy picture with it in a scale bar consisting of a Corvette or something like that and a sunbather on the surface of what was the Itakawa, which is really handy. Like, okay, that's how big those boulders are.
Right.
And the fact that those boulders are so big is actually a problem for OsirisRex, which you can tell us about a little bit later. Speaking of asteroids hitting things, or things hitting asteroids, there's a conference going on talking about what would happen or how would we react to a scenario if we discovered that an asteroid was on a collision course with the Earth, or potentially on a collision course with the Earth. And as it happens, a fairly large asteroid named Apophis is going to make a relatively close flyby to the Earth in the relatively near future. In 2029, it will, and it's about a 340 meter diameter asteroid, and it will fly by at a closer distance than the moon to the Earth. So no chance of it hitting this time around.
Yeah, I remember talking about this 10 years ago or so when we
Yeah.
didn't have as good
An orbit.
constraints on its orbit. One in the chances of it hitting were still small, but
Not zero.
Not zero. And I guess especially the next time it comes around, because it's on an orbit that will take it close to the Earth, reasonably often, and the little bit of interaction it has with Earth this time will cause its orbit to change just a little bit, and could potentially cause it to hit next time. Although I guess nowadays those percentages are getting smaller and smaller as we get a better idea of exactly what its orbit looks like.
Yeah.
So, if I recall correctly, and I may not, I thought that the last time there was an Apophis scare, it was the highest number an asteroid had ever been given on the Torino scale, which is the impact threat hazard scale.
Is that the Gran Torino scale?
It is different than that. It's
Okay.
just the Torino scale.
Okay.
So that's a fact that may or may not be real.
One of those it's a potential fact.
Potential fact.
Which we have to open the box to see if the fact flips
That's
to
right.
the real
It's
state
Schrodinger's
or
fact.
the hypothetical state. It's a close enough passing asteroid to the Earth on this occasion, and potentially on the next several encounters, that discussions about, oh, it's coming by in 10 years, we can do some scientific experiments to study the asteroid in particular, what it's made of, and things like that. And some of those potential experiments could affect its orbit by tiny amounts. But then what happens if, like, oh shoot, if we hadn't done that mission in 2029, this
Right.
this life-destroying asteroid would not actually be on a collision course with the Earth in the year 2050 or whatever.
Right.
So it's you want to be careful with things like that, and that's why this conference is saying, well, what do you do when you encounter that sort of situation? Probably not what was done in the amazing 1998 blockbuster starring Josh Colwell, Deep Impact,
Starring.
available on streaming services and DVD and Blu-ray.
And VHS.
Betamax. I suppose. I might even have a VHS of it. At one point I was like, I'm going to get that movie on every single format, so I have VHS Laserdisc.
Nice.
Ooh.
I think I must still have the Laserdisc of
Do you
it.
have a Laserdisc player?
I think I got rid of it. I had a really nice
They're-
Laserdisc player, but they're bulky.
Yeah, I
I
didn't
might-
think any of those still existed in the world.
Well, sure they exist.
I mean,
in the
other than a
world.
museum.
In a museum.
Museum.
A museum.
Museum. say words wrong.
I have to check, and I don't remember if I still have it, because we have some, anyway, nobody cares about my laser discs. Moving up in scale on the impact from planet destroying, black hole collision discoveries are going to be popping up in our news feeds more frequently.
Yeah. So LIGO, of course, we've talked a bunch about some of the the very first black hole merger that we saw some years ago, and we've mentioned it a few times since. Even I think maybe on the last episode or one of the last couple episodes we talked about LIGO. Well, they're in their kind of third operational run that just started a couple months ago, and they've already seen just in the first month of this 03, which is like the third operational run. They've already seen in the first month like 5 signatures. So. And one of them seems to be, although it needs more analysis, this collision between a black hole and a neutron star, which was the very thing in the episode a couple of episodes ago that we said, if we had that
would be cool to see.
That would be really awesome, because we've seen lots of black hole mergers, and we'd seen one really awesome neutron star merger. If we saw the mix, that was going to give us this really great, useful thing in cosmology. And we mentioned that last time with measuring the Hubble parameter and so forth.
It's a distance scale measurement,
Yes.
because you can figure out how far away the neutron star is precisely from other means. Is that right?
Right. So
because you can see the neutron star.
You can see the neutron star. Now this one is a little bit tricky because the signal is weak, and we're having a hard time localizing it in the sky. So it has not yet been identified using light, but it may well be at some point.
And if we saw one in the first month,
that's statistically speaking,
they may be more good. So this is very exciting. Yeah.
Hopefully more will be following.
LIGO, go on with your bad self.
Speaking,
Oh, I was just going to say, fun fact about LIGO is that there's citizen science contributing to that as well. So if anybody can go and help the LIGO
Is it like
team.
LIGO at home or something?
It's called Gravity Spy, and you can help categorize noise so that to train the computer algorithms to get rid of background signals.
Okay, cool. We will post links to that on our Facebook page and website. Speaking of black holes, there's an observation of a gobsmackingly rapidly spinning black hole, according to study authors. The study author was gobsmacked. And speaking of black hole mergers and those sorts of things, which convert lots of matter to energy, this episode of Walkabout the Galaxy is brought to you by E=mc². The best known equation on the planet is here to provide you sunlight to power your residential solar panels, keep your planet from being a dead frozen chunk of rock floating through an ink black sky, and grow your food. A little bit of M goes a very long way thanks to E=mc². E=mc², the quicker picker-upper.
That has got to be the most famous equation of all time, right? If you ask.
But not the best understood.
Definitely not the best understood. Well,
maybe not the worst understood, but not the best
not
understood.
the best understood.
I mean,
I
as
think a lot of
equations go.
Yeah, people know E is energy, I think, a lot. But anyway, if you go to the street and say, name an equation,
E=mc².
E=mc² is going to be the one.
In my classes, anytime we come to the point in a course like astronomy or an energy course I just taught, and that equation comes up, that's how I introduce it. What is the most famous equation?
Yeah.
That is the resounding choice.
Mm-hmm.
I think we've talked about what's your favorite equations. Do you have a favorite equation?
No.
No? Yours is
come back to me.
G equals 8 pi T over R, or 8 pi R over T. 8 pi
Something
T
like that.
R, something like that.
Pies.
G sub mu nu equals 0.
There you go.
Right.
There you go.
I'm a simpleton, so mine is F equals ma.
F equals ma.
Oh, that's a nice
Beautiful
one.
equation.
That's a nice
Beautiful.
Yeah. Not always right.
Not always right, but right enough.
Right most of the time.
But in my world, my little simple world, always right. In other space news, did you see this thing that they have tracked down, they believe telescopically, the Apollo 10 lunar excursion module?
Yeah, so that's a little bit of a weird story.
It is a very weird story. I didn't know anything about this until it popped up in the news.
Yeah, so I tried to track down the original. So there was a story on the Daily Mail about it, which is not maybe
not an authoritative
most,
scientific source.
So I tried to track down the person they had quoted as the sort of lead of this study, And on his Twitter, he said, no, go to the Times, I think the Time,
Okay.
and which is UK publication. That's where the real story is, and don't listen to anything on this Daily Mail thing. And then I couldn't think, it was behind a paywall. So
Okay.
so I don't know the real story.
Well, we will not promulgate unverified fact and muddy the waters. Suffice it to say that what happened with Apollo 10, as planned, that was a dress rehearsal for and we're in this is the 50th, this year's the 50th anniversary of the first landing of humans on the moon with Apollo 11 in the summer of 1969. And right now is probably right about the 20th anniversary as we're recording this of Apollo 10, which is a couple months prior to that. Apollo 8 was Christmas of 68. I don't remember what, about 9, and then 10, they they went to the moon, they're orbiting the moon, and they separated the lunar excursion module, which in 11 and the later missions lands on the surface of the moon, but they left it in space. And it was not predicted to crash in the moon or anything like that. So it's still out there in the solar system somewhere, and we will post on our websites the definitive story about what may or may not have happened in terms of uncovering it, but there was some discussion about, oh, there it is, cool, let's go get it, put it in a museum. Or not. So we mentioned that Blue Origin launched their suborbital vehicle yesterday, carrying a bunch of experiments, including one from CHARM astroquark Addie Dove.
Go nice.
So that's exciting.
Very cool.
We've had multiple experiments now fly on that vehicle. That whole ride is 10 minutes.
That's crazy, right? You spend so much
That's
time,
wild.
I say you, I mean, it was really you guys, obviously, but so much time preparing the experiment and thinking about it and designing it, and 10 minutes does
Right.
it, and that's over.
Up and down. And similarly, if you're somebody who's contemplating buying a passenger ride
Right.
on these things.
How much does that run you?
They haven't announced a price, but on Virgin Galactic Spaceship 2, it's $250,000, I think.
Ooh, $250,000.
Yeah, and their total time in the air experience is longer because they're an air-launched rocket with Virgin Galactic. So you're going to spend a fair amount of time in the spaceship mounted to the bottom of their large carrier airplane. So
Right.
I don't know, half an hour or something like that to an hour to get up to
But that's not what you're paying
45,000
for.
feet. No, it still might be kind of cool.
Yeah.
But not worth $250,000. But then the time in space is the same. That's just ballistic trajectory of going up to 100 kilometers or so.
Right.
So kind of interesting. And if you're paying a lot of money to do that,
Yeah.
that's a short ride.
It
I was
is
thinking
short.
about,
But of course, if you're a billionaire,
Well,
Yeah,
$250,000
that's
is
just
to
nothing.
you like
It's
$20 to me,
meaningless.
right? So
Right.
I'd pay $20 to go out there.
Yeah.
I wouldn't pay
I mean-
$250,000.
I mean, that's less than bribe your kids into college money.
That's true.
So the equivalent calculation I make is like, okay, how long am I willing to stand in line to go on the Avatar ride at Disney's Animal Kingdom? And it's a 5-minute ride, so I'm like,
Yeah.
well, I'm willing to stand in line for an hour and 15 minutes to do that ride. And so just scale that up, I'm willing to spend $250,000 to spend 10 minutes on a rocket. Where only 3 minutes of that or something like that is in space.
Right.
But speaking of Blue Origin, they tweeted a teaser tweet called a tweezer earlier this week with a picture of Shackleton's boat in the ice of Antarctica, and then the date May 9th, 2019, which is a few days from now as
Oh.
we're recording this, but maybe in the past when you hear this. So they're making an announcement on May 9th, 2019. The clue to what the content of that announcement is the picture of Shackleton's ship in the Antarctic ice. Any speculation from the two of you about what that announcement might concern?
No.
All right,
I'm
well,
blank.
Something
free
is in ice.
associate. No, think about Shackleton.
My Antarctic history is.
No. Shackleton. I know you know this.
Shackleton?
Shackleton crater
Oh.
on the south pole of the moon.
Okay.
Ooh, they want to go to the South Pole and look at some cold traps, maybe.
I'm just saying, there is a crater on the south pole of the moon called Shackleton Crater. And as Zoe said, it's in this sort of permanently shadowed region.
The PSRs.
Yes, yes. So maybe it has something to do with that, missions to the moon. We'll see.
Okay.
Interesting.
All right.
They have previously, so their current rocket that they're flying, that Addie's experiment was on, called New Shepard, named after Alan Shepard, who rode the first Mercury astronaut suborbital flight. They're currently building down the road from us their reusable orbital vehicle called New Glenn, after John Glenn, who was the first American to do orbital flight. And they have previously tweeted the future existence of a rocket called, can you guess? Come on, you can guess.
Addie, we need you.
New Shepard. He was the first American to do a thing.
Who was
New
the first
Glenn.
guy on the moon?
I don't know, Mickey Mouse? I'm just kidding.
Don't kid about things like this.
New Aldrin.
I don't think.
New Armstrong.
New Armstrong.
So they have
We're just giving you a hard time.
They have tweeted that. So maybe this announcement has something to do with New Armstrong development. Maybe it has something to do with some of their. I don't know.
I mean, if you
We'll
believe
see.
that people went to the moon.
Oh, please.
Just
It's been
kidding.
too long a
Just
week.
kidding.
It's been too long a week for those kinds of jokes. So the that announcement will be interesting to see what is going on with that. And then other space news. Addie, who's on a roll,
All right.
has an experiment that's going up to the International Space Station potentially in less than 24 hours on the next SpaceX cargo supply delivery mission to the ISS.
Nice.
So
This is
lots of space news for the astroquark.
yeah,
I was going
this
to
is
say
a big-
astroquarks, but it's really just the
Big week for
the
charm quark.
astroquark. Right. Yeah. So let's get to our topics with that 20-minute introductory bit. So the 20-meter crater on Ryugu, I think we've already basically touched about that. We have mentioned this previously, that the Japanese mission Hayabusa 2 has had several little landers go down to the surface, and they're a sample return, and they have retrieved, in principle, some material from a sample, one of which they did by shooting a bullet at sort of slow speeds for a bullet, but still it would hurt like hell if it hit you. And that created a sort of splash of rocks, some of which hopefully went into their collector mechanism, which will come back to the Earth in a few years. Then this other collection idea was, let's dig a hole and then get stuff from the bottom of that hole. So now we know that they have successfully dug that hole.
So how do they get the stuff from the bottom of the hole? Go down and
I
Is there
think
like
they'll
a
be
s- like
doing. I don't know for sure if they're using the same technique that they used previously, which is the bullet and knockoff technique, or if they've got a different collection technique for that one.
I don't know.
But OsirisRex, the NASA mission, which is currently orbiting a similarly sized but very different sort of asteroid named Bennu, is going to be collecting stuff from that asteroid, and it is using a very different technique. If you want to tell us about that.
Yeah, I hope I don't say something wrong, but I think that what OsirisRex does is it contacts the surface and it puts like a little puff of gas. I think it's nitrogen gas, to make a little plume of dust that it will then be able to sort of collect in a, I'm not sure if there's I don't think there's like a vacuum mechanism. I think it's just
No.
it just falls in there essentially.
Yeah, it's blast the stuff up
Up
and
and
you've
then
got
it's trapped.
a box that the stuff hopefully goes
falls
into.
into. So, but there's a problem, which is that there doesn't seem to be a whole lot of dusty stuff on the surface. It's very, very rocky, blocky, chunky, bouldery, and there are some areas that look dustier, but they're not as big as the navigation team would feel comfortable with. So you have to worry, the spacecraft has to get very close to the surface, and then if it collides with a big giant boulder sticking up, then you've lost your spacecraft.
Yeah, the surface is rough enough so that their arm that's going to do that puff and collect activity is about 2 meters long.
Yeah.
And so if you're going down to do this, and of course it's doing it basically by remote control, not by remote control, but autonomously. Like you say, okay, here's your spot, go do the best you can. and then you hope it works. And if as it's going down, if it happens that there's a boulder that's 2 meters tall,
Yeah.
and your arm is going down next to it, then that 2 meter tall boulder smacks into your solar panels of your spacecraft, then you really
That's
have a
bad news.
problem.
And it's bad news.
So they're having a hard time to find nice smooth areas on that asteroid to do this, and that's not happening for a while, like more than a year from now before they
Yeah.
do that.
Yeah, that's
So
right.
they got plenty of
They have
time to scope things out.
That's
Yeah.
right, yeah.
Interesting. Let's see. We talked a little bit about Apophis already. Before we get to the larger scale stuff, black holes and the magma ocean in the Earth's ancient past, let me go ahead and hit our trivia question
yeah.
for you. So I mentioned, do you remember what the adjective was for
Historical.
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 Was it historical? It's all, that's right. It's historical, and it relates to the Stumpers. So it is historical, avengical,
Okay.
but it's mainly historical. It's inspired by the Avengers. The Marvel Cinematic Universe has famously wrapped up its long story arc with the new movie Endgame. Have you seen that yet?
Which we haven't seen.
Okay.
We should probably
No.
discuss
So
on the next episode.
We will. So
Walkabout,
there's no
yeah.
spoiler
No
alerts
spoilers,
because we can't
none
spoil
of us
it.
have seen it.
Prior to that, we had Avengers Infinity War. I know there was Captain Marvel immediately prior, but Infinity War was a year ago or something like that, sometime last year. And while the title of Infinity War doesn't specify whether that infinity refers to space or time or both, I don't know. Did you see Infinity War?
Yes.
There's Infinity Stones.
There are Infinity Stones, so maybe it's the war about the Infinity Stones. I don't know why.
That's what I assume.
Yeah.
I don't know what the Infinity
Why
Stones
the
refers
stones are called
to.
Infinity, right? Anyway, today's trivia is about the longest war in recorded human history.
Oh.
So that's a stretch. It's a big stretch for a trivia for an astronomy podcast.
Sure.
We're going to expose our ignorance. Although I guess almost every
That's,
trivia question exposes our ignorance.
that's my goal
Yeah.
every episode.
Yeah.
Unless it's the Star Wars.
Okay. Oh, I don't want to forget to mention that Peter Mayhew, who
Oh,
played Chewbacca,
yeah.
died this week, and so very fond place in everybody's heart who is a Star Wars fan. The longest wars in human history were probably, you've heard of the 100 Years' War.
I have.
Yeah, right.
That was
So
where
you're
my
not
mind went when you...
You're
Yeah.
not completely ignorant about human history and wars. So those are probably not like every single day fighting.
Just war
Right.
for 100 years.
But that's the kind of thing we're talking about here.
Okay.
So what is the duration? Your question is, what is the duration of the longest war recognized by historians? Closest answer wins, not price of right rules. Bonus points for also guessing any or all of the following: the start date, the end date, or any of the combatants.
Yikes.
So think about it.
Okay.
Mull it over while we're talking about the impact that formed the Earth's moon.
Right. So is that my cue?
That is your cue.
That's my cue. So
Anybody's cue wants to talk about it.
anybody wants to jump in? There is a new paper out about the origin of the moon, Earth's moon, published in Nature Geoscience. And the idea with the formation of the moon that has been prevailing idea is that the moon was formed by an impact into the sort of early Earth by something called Theia. So there was a giant impact, and the stuff that flung out turned into the moon. But it's weird that there isn't really a chemical difference in the moon and between the rocks in the moon and the Earth that would indicate there's some other body in there. And that's been
Because that Theia was like the size of Mars or something.
Right. And it's been puzzling for a while because to have everything just be the same material, the orbit,
Perfectly mixed.
yeah, the
sort of.
orbit that you would need is not very likely. So the new idea is that the Earth was totally molten when Theia hit it.
Had not yet solidified, or
Right.
was molten because
Not
something else
totally
had
molten.
happened?
Sorry, it hit a magma ocean. So the surface was totally molten.
Okay.
And for some reason that I don't fully understand, but I'm sure is described well in the paper that I didn't read, having the surface of the Earth be molten would solve this kind of conundrum of why is there no Theia signature
How
in
do
the
you
moon?
get a molten surface without a molten interior. Like when planets first form, they're hot.
Have you
Because
been to the beach?
Yeah, I've been to the beach.
That's a molten surface.
Yeah, but underneath is not solid the same surface, right?
No.
Generally the Earth is warmer the farther down you go.
Uh-huh.
And obviously if you go far enough down, the pressure becomes very great and
It's possible I'm
things
just saying
become
this
more
wrong.
viscous, but
No, the moon also had at some point
Magma
had a
ocean.
magma ocean as well. So that's my understanding is that's the phase of the planet cooling off by transporting lots of material physically to the surface from the interior. So it's not like I got a solid rock and I've got this molten rock sitting on the top. I'm pumping liquid rock out from the interior onto the surface.
okay.
Yeah, that
And,
sounds
and
right
that's
to me.
flooding the surface on a global scale because there's
Sounds
so
right
much
to
of it.
me.
Fair enough.
Okay.
So
Sounds good.
that's all I got on that.
Okay. So
But that would be, I mean, that's a
does
nice.
that put a new constraint on what the early energy budget of the Earth was?
I don't know.
Or does
Maybe.
that maybe put constraints on when this impact happened? I mean,
Probably,
I guess
but I
more
don't
like
know.
what you
do
know,
that,
yeah.
right? Yeah, because we have pretty good dates on some of from the moon rocks that were returned by the Apollo astronauts, been radioactively dated. So we've got a pretty precise date
Yeah,
for that. We have a pretty precise date for the first solidification of materials in the protoplanetary nebula around the sun from meteorites. Those things are nailed down to the sort of million-year level
yeah,
or so, which is pretty remarkable.
yeah. I mean, I think the argument in this paper is mostly a compositional one. This explains compositions that you see
Why the moon looks so similar compositionally
to the Earth, right? And that this model also satisfies conservation of angular momentum in physics, so
Right.
it doesn't require any weird, very unlikely impact scenarios, or
Right.
orbits to happen.
Yeah, one of the big constraints on those impacts, as you mentioned, is the angular momentum, because you have a Mars-sized thing hitting an Earth-sized thing. If it hits head-on, you get a very different out. You get a big splat, but not stuff
Right.
in orbit, which you
Right.
need stuff in orbit to make the moon.
Right.
And if you hit it too glancing, then you put too much angular momentum into the system, and that doesn't agree either.
Right.
So
So this would take care of that.
okay, moving up in scale back to the black holes.
Ooh, black holes.
Everybody's favorite astronomy topic. So we have already alluded to we're sort of looking forward to a steady stream of new black hole collision discoveries and neutron star, black hole, all sorts of things from LIGO and the updated detection capabilities for the gravitational wave. There's another unrelated black hole news story that relates general relativity and Jim's favorite equation, G equals 18 pi.
So yeah, I mean, obviously the only way, gravitational waves are not the only way in which we detect black holes. We can see black holes often because they spew off very high energy radiation as they munch material from surrounding stars or other stuff.
Technical term.
Stuff.
Star munching.
Munch, yeah.
So very often you have, a black hole in a binary star system, or as one of the pair of a binary star system, and there's a regular star as the other pair. The regular star wanders a little close to the black hole starts to steal material off of that other star, make this accretion disk around the black hole, and that stuff slowly kind of falls into the black hole, and as it does so, it gets really, really, really hot, and interactions between that hot disk and the black hole cause these powerful beams of radiation to be shot away from the spin axis of the black hole. So we see that a lot of times, and it's a pretty cool phenomenon. But this most recent finding was a cool look at a beam of radiation coming from the pole of a black hole that was sweeping around very, very quickly. So
Or like a wobbling top.
it's like a wobbling top, right? And it's weird because basically what that implies is that the spin axis of the black hole is not the same as the plane of the accretion disk. So that is, the orbit of the black hole around the star is not in the same plane as the spin of the black hole, which I guess is not terribly weird. But I guess the kind of cool part about all this, the take-home message is, the reason that it does this really cool beaming spinning thing is it's the black hole as it spins around is taking space itself and causing the space to be spun around it. Black holes just what do we call that effect?
Frame dragging.
Frame dragging, which is this cool right. You're taking frame dragging because it's like dragging the frame of reference that it's sitting in along with it, which is very bizarre. It's taking the space in which is sitting and it's spinning that around. We've measured that with the Earth. With the Earth, right? So we had this thing called Gravity Probe B. I think I have the right thing where
Yes.
we were measuring that it's a very tiny effect for Earth because Earth's mass, Earth's gravitational field is pathetically weak compared to something like a neutron star or a black hole, but still measurable. And so we measured that effect, and here is an extreme example of it. It takes the space around it, which is filled with all this accretion stuff, and it drags it, and as it drags it, it causes these really cool lighthousey effects that we're seeing. So,
Of all the mind-blowing aspects of general relativity, frame dragging is the one that I find the hardest to wrap my head around at all. And it's like, I just don't get it unless I think of space as like some gooey fluid.
Or
right.
like a fabric.
That you're tied. It's just I don't.
Something
It
with
is,
viscosity
you know.
or
Right,
Yeah.
yes.
Yeah.
It makes me think of the luminiferous ether.
Right.
You know, as something. So it's very mind bending. Okay, your historical guesses. We're looking for any of the following: start date, end date, duration, combatants for the Earth's Infinity War.
Okay. Duration was in that list, right?
Yes.
Okay. Sorry.
yeah, I could make a guess for the duration.
Well, you can make a guess for all three.
I
Probably.
could
All
make a
four.
guess.
Yes. Well, make a guess for the duration. We'll start with that. Then I'll put you out of your misery.
Zoe, you want to go first?
Oh, sure. 110 years.
153 years.
Oh, you're such optimists and pacifists at
Oh,
heart.
no.
I think 110 years is the actual duration of the 100 Years' War.
Oh,
Yeah.
man.
Then there was another war called the Second 100 Years' War. At least one of those was 110 years.
Oh, no.
No, 781 years, my friends.
What?
Yes.
781 years.
And obviously, there's not every single day of those 781 years is there a battle being waged. So
Right.
that's why I prefaced with the recognized by historians. And when do you think this happened? Pick a millennium or two.
A long 100.
Starting in 100?
Yes, the year 100.
Starting in the year
Starting
100.
near
Or including the
1000.
year 100. No, from 711 to 1492.
Oh,
Oh.
Yeah. Location?
China.
I don't know. Sorry. I can think of no locations on Earth currently.
There are no locations on Earth inhabited by people in that time frame.
That's right, yeah.
No continents.
No,
come to mind.
Can't name a single one.
The Iberian Peninsula, Spain and
Oh,
Portugal.
really?
It's basically between Christians and Moors
Moors.
coming from northern Africa, and a fight over that peninsula, basically.
Did not know that.
Did not know that either.
Yeah. Here's a ridiculous bonus trivia, which is it's truly bogus bonus. What's the silliest war in human history? The question is a clue, and you'll never get it. So the answer is it's not really, it's silly for two reasons. One, it wasn't really probably a technical state of war. And two, it was between the Netherlands and the Isles of Scilly. If I'm pronouncing that correctly, Scilly.
Oh.
Listeners can correct me if I'm wrong, as I have been in the past, which are off the southwest coast of England, off Cornwall. 335 years. So what happened is there's some ridiculous thing fallout after the end of the English Civil War. Listeners, please correct me as I mangle your history. And the Dutch were allied with a side between the parliamentarians and the royalists in England, and the royalists sort of were pushed to the Isles of Scilly, and somebody named, believe it or not, Tromp, Tromp, was dispatched by the Dutch to the Isles of Scilly allegedly,
Huh.
with some orders to take some sort of violent action. And why is this in this list of war thing? Because the Isles of Scilly were not a nation, so they couldn't really be in a state of war. But at some point, somebody decided, hey, maybe there's technically a state of war here. And so in the year 1986, on April 17th, because of a discovery by a historian, Roy Duncan, regarding this incident in 1651, invited the Dutch ambassador to Great Britain to visit Scilly and sign a so-called peace treaty to put to rest any doubts about whether or not there may be a state of war between the Netherlands and the Isle of Scilly. So that's a silly note to end the podcast on. While it may have felt like the longest war in human history, it's just another episode of Walkabout the Galaxy. Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com. We're also occasionally on YouTube at Walkabout the Galaxy, where you can see us looking bewildered by what the other person just said. Thanks to our listeners in New York City and around the world. Follow us on Twitter
At walk_the_galaxy.
where you can ask us questions and suggest topics that you'd like to hear us discuss. Our theme music was composed by Richard Jerusik. Our production assistant is Diego Rodriguez. Catch up on old episodes wherever you get your podcasts, and write us a review where everybody can read it. And less it's a bad review. I'm Josh Caldwell. Somebody else is in the room with me.
I'm Zoe Landsman.
I'm Jim Cooney.
We're the AstroQuarks, signing off until the next episode of Walkabout the Galaxy. Yay. Okay.
All right. Sorry,
So-
I couldn't think of any
I forgot.
things.
So every episode I do a script, and the things that are new each episode I replace with XXX, and then I fill those in. And it's like, and write us a review, XXX. That was it. I
Forgot to put
I was,
it back in.
forgot